Hi Year 12s, I'm going to go through the January assessment question 7b. Okay, the first part we've got show that, so that means we have to show all our working. Show that this equation can be written in the form y equals ax squared plus b, where a and b are integers, so we have to go for that format. Okay, so I'm going to write down that equation first of all. So what we've got, so it was log base 2 of y plus 1 minus 1 is equal to 2 log base 2 of x. So I'm going to show you two approaches, but essentially if we want to write that equation so that it no longer has logs in it, if we've got lots of logs, we want to combine it to make a single log. And on questions where you're given a single log, you usually want to expand it to make lots of logs. So we use our log rules. So here's my first approach. I'm just going to kind of go straight at it as it's facing me. I can't really simplify this first term. Okay, but ultimately I want to combine everything to be logs. So I'm going to change 1 into log base 2 of 2, because everything else is log base 2. Okay, and then this one we could apply our log rule. So we've got log base 2 of x squared. We bring the power up. Okay, now we can combine these two logs. When we have subtraction, that is the same as doing log base 2 of y plus 1 over 2. Okay, and that has to be log base 2 of x squared. So now we have log of one thing equals log of the other thing. So these two things have to be equal. Okay, so now we can rearrange it to make y the subject. So oops, missed the 2. There we go, 2x squared minus 1. Then we double check by looking at the question. Can be written in the form y equals ax squared plus b, where a and b are integers. Yep, that works. Okay, right, a slightly different approach might be to put all your logs on one side. So log base 2 of y plus 1 minus 1 is 2 log base 2 of x. Okay, so this time what I'm going to do is I'm going to move my logs all to one side and put my 1 on the other side. Okay, then I'm going to combine my logs, but I have a problem here because I've got different things here but under 2. So I'm going to use my power rule for my logs. Okay. Right, now I've got a subtraction, so I can combine the logs. So I've got log 2 base 2 of y plus 1 over x squared. Okay, so we've used two rules in both methods. We have used the power rule, so the 2 can come up to the power here. And we've also done the subtraction rule in both cases, where we do the first thing divided by the second. Okay, that equals 1. Alright, and now I'm going to do number answer power, okay, or base answer power. So there's my base, this is my answer, and this is going to be my power. Or you might know it as number answer power, so BAP or NAP. Okay, so my base is 2, my power is 1, and that equals my answer. Okay, so that's 2 to the power 1, so I'm going to multiply, or you might simply remember actually that log base anything of the same base is equal to 1. Yep, so you know that log base 2 of 2 equals 1. So you would know that the bit in the bracket has to equal 2. Alright, so it's either memory or it's applying, converting a log into a power equation. Okay, so let's multiply through by x squared. Okay, and it's just the same as before, isn't it? Just on the other side. Okay, right, let's have a look at part B. So this is quite a challenging question. So we've got a hence, solve. Now there's not a determine, there's not a show that, so you are allowed to use your calculator to help if you want to, but hence means you need to use your previous answer. Okay, so what are we hensing? So we've got simultaneous equations, log base 2 of y plus 1 minus 1 equals 2 log base 2 of x. So we should recognize that equation from the previous question, and we established that this is exactly equivalent to, so this is equation A. Equation A is exactly equivalent to y equals 2x squared minus 1. Okay, so let's look at the second equation, which I'll call B. So we've got log base 2 of y minus 10x plus 14 is equal to 0. Okay, right, and again from either memory or using the base answer power thing, okay, we should know that this bit in the brackets is 1. Let's just see that. So if we're using base answer power, so the power is 0, okay, and the answer is, okay, so that's just converting it to a power rule, or you can remember that this has to be 1 to get an answer of 0. So 2 to 0 is 1. Okay, so now our simultaneous equations are in a nicer format for us to solve, aren't they? Because they're just nice normal algebra without any logs. And we can substitute A into B. Okay, so let's do that. So we've got 1 is equal to 2x squared minus 1 minus 10x plus 14. This is a quadratic, so we make it equal 0. Okay, luckily they're all even. Okay, obviously from here you could use your calculator to solve it, alright, which is sensible to check your answer at the end, just to make sure it hasn't gone horribly wrong. Okay, so those are our two x values. I'm going to just recheck the question. Hence, solve the simultaneous equations, so that means we need both y and x. So in this case, we've got y is equal to, using the equation A, 2 times 2 squared minus 1, so that turns out to be 7. Okay, so that's one set of solutions. Or y is 2 times 3 squared minus 1, which turns out to be 17. Okay, and I've made it very clear that these solutions pair up.